Hello, thank you everyone for coming. My name is Spela Poklukar, and today I'm going to talk about reproducibility and versioning of machine learning systems. Oh, I forgot my pointer. Here it is. So before I begin, let me just briefly introduce myself. Again, my name is Spela Poklukar. I'm a machine learning consultant. Currently, I'm employed in company Endava, where I am taking the role of data discipline lead in Ljubljana, Slovenia. This is where I'm based. I am also very active in our innovation community, and I am a lead of our gender balance work stream of our diversity and inclusion forum. So the agenda for today is the following. So we're going to start with motivation. We're going to define what reproducibility means. Then we will explain what are the benefits, why do we even care for reproducibility. Then we'll continue to modularity. So we're going to see how modular code can help us with ensuring reproducibility. And the main part, of course, will be versioning. How do we track different changes of our machine learning systems and how do we version them? And then the last very quick note about documentation. Okay, so let's start with motivation. So what reproducibility is? So we often hear about reproducibility in two different contexts. So one in the context of machine learning research and the other one in the context of having machine learning, let's say, in production. So what are the differences and why it basically means the same thing? So machine learning in research, this means that we are able to take the work of someone else, to take a machine learning workflow, and recreate it recreate it ourselves, and in the end obtains the same or at least similar results. Whereas in machine learning system, reproducibility of machine learning systems, let's say in production, this basically means that we are able to reproduce our own results. So basically, if we run our machine learning workflow several times, that we are able, again, to achieve the same or at least similar results. So basically, we can see that this is pretty much the same thing. So either we rerun the work of someone else or our own work, but the point is that we are able to each time get the same results. So I will be talking about the second one, so the reproducibility of machine learning systems as such. I do not come from academia, so this is the place where I feel more comfortable. Okay, so the motivation. Why do we care? Why do we want to have reproducibility? So first of all, if we start with research, so to have reproducibility research, this means this is some sort of evidence that the results really are accurate and significant. Also, this can be a proof that the gains that we get from introducing a certain method, for example, really come from this approach and are not due to some random factors. And then if we have an idea how to reproduce the results, this allows us to better estimate the cost of using such system, such research. Then reproducibility in let's say, production. So why do we want to have that? So there are several reasons for that. So the first is that if we can reproduce the results that we get during development, if we can reproduce them in production, you would probably agree that this is a good sign. Then fault tolerance. So imagine if we are running our system and each time getting different results, this would make our job of spotting the errors much harder, right? So this is also one reason. Scaling. So if we are able to reproduce different parts of our machine learning, we can easily kind of scale different parts, and so this is also a good thing. Model rollback. Imagine if we have already deployed model in the production and we are not satisfied with the performance of that model. This allows us to just simply roll back to the previous version of the model. Then there is a cultural aspect. This creates trust and credibility of machine learning products. And of course, we need to adhere to increasing regulation constraints. So I hope that you are not convinced that reproducibility is really something that we would like to achieve. And now just a quick note on modularity. So imagine different pipelines, for example, that you encounter during the life of your machine learning project. So first, let's start with development pipeline. So normally it looks something like this. We have data pre-processing, feature engineering, model training, then we have some prediction service that we use to evaluate the model. So this is kind of like a simplified development pipeline. But training pipeline, so imagine that we have developed some model, we are quite satisfied with it, we want to put it in production. So the training pipeline should look something similar to that. So we still have data pre-processing, feature engineering, model training, and then let's suppose that we stored trained model in some sort of storage. Inference pipeline, so probably something similar. We will have to pre-process the new data that comes, feature engineer, and then let's suppose that we grab the model from the storage where it was saved after training and use it in the prediction service. So we can see that we have quite some parts of the code of our system that are kind of overlapping. So having the code modular, like separated different part, if we separate different parts of our pipeline into different components, whether with different models or say if we're using microservice-oriented architecture, this allows us to chain the same components in different workflow. So this is also one way to ensure that we are using exact same feature engineering when we are developing the model and the same features than we are using in production. Okay, so this was just a brief note, but let's now come to the main part of the presentation. We're going to talk about versioning. So reproducibility is mostly about tracking and versioning every change in our machine learning system. So first of all, let's try to just see what are the changes, what are the parameters that we have to track in order to really be able to reproduce the exact same results on the second run, for example. So we have a lot of data parameters. We have a version of our data set. We have the timestamp where the data became available, train test split, shuffling of the data set, pre-processing parameters, maybe some target variable transformation, if any. Then we have a lot of model parameters, feature parameters, feature selection process, model type architecture, hyperparameters, weight serialization, dropout, evaluation, and then of course we have also some system parameters, source code of course, then we have the definition of our workflow, dependencies, certain libraries that we use, environment variables, infrastructure, maybe some floating point calculation, and God knows what. This list is for sure not exhaustive. But one thing that we have to keep in mind that if we take just single of those parameters and change it, we might not anymore get the same results, right? So we have to track all the changes really to ensure our reproducibility. So there is quite a lot of things to keep in mind, and this is probably this is not an easy task, and it's well known in data science community that once we start to work on machine learning infrastructure, that time is running differently. But luckily, we do have certain tools at our disposal that can help us with that, and till the rest of the presentation, we're going to talk about different tools that help us. So before we begin, let me just mention something very obvious. So what is the tool that is commonly used for tracking the changes in versioning? It's Git, right? So this is something that everyone uses, and what it allows us is to push our changes, and then each change has its own version, so it has some commit ID, to which we are able to return at some previous point and just recreate get the same code that we had at certain point in time. So Git is something that is really well-known tool for that. But machine learning, as we've seen, is quite a lot different than software engineering. It has it's much more complex. So let's start with some tools that are special for machine learning. So first of all, experiment tracking. I think that everyone has been in position where we have run different experiments, we've tried so many different things, and in the end we just didn't know anymore which experiment produced which results, and in the end we're just confused and have no idea what we're doing. So experiment tracking tools, there are quite a lot of them. They actually help us exactly that, to track the changes that we're doing during our experiments. So we are tracking the parameters that we're changing. And in the end, we also kind of change the metrics that we get during evaluation, and that these two are kind of connected. So what parameters that we change and the results that we get. So why this is good? Of course, this kind of tool allows us to compare different results. We see which results are if we change certain things, and this allows us to, it helps us with selecting the best model. But once we do select the best model, we can then see what parameters have we changed, and this kind of allows us to reproduce this system also in the production, so we can get the same results. Dataset versioning. I'm not going to talk too much about that because normally this is not the job of data scientists. This is something that normally data engineers would do. But imagine if we do have a certain project that that doesn't have a data pipeline established. I would just like to mention a tool. It's called DVC, Data Version Control. Which is built on top of Git, and it allows us to version our data set. So this is, let's say, more lightweight solution that a data scientist can use for that. Feature versioning. So we have a very interesting concept that is not around for that long. It's called feature store. So what feature store is, it's a central location where all the features are pre-computed and stored. And from where they are stored somewhere, and then we can have different parts of the workflow. For example, we can use those pre-computed features when we are developing model, for training, for inference. So basically, this is kind of the idea of the feature store. And this approach is opposed to, for example, if we compute features on the fly in each workflow when we need them. So why this approach? Why can we argue that this approach is better? So there are several benefits. So for one thing is, of course, consistent use of features during development in different pipelines. So with this, we can ensure reproducibility because we grab the features from the same storage, from the same location in all the pipelines. It's also a collaborative unit. So, for example, data engineers can store their features, the features that are computed in the feature store, and then from there they are used by data scientists where they are developing, or maybe by MLOps engineers who grab those features and use them in training and inference pipeline, for example. It's also some legal teams can take them, or compliance teams, to make sure that we are using our data in a compliant way. Also, it accelerates innovation because in the organization, because the features are already there, computed, and some other data science teams who are working on some similar problems can just see if some features are useful for them and just grab it and skip the development of that features. Then we have a point-in-time lookup. So what does it mean? So a feature store should be able to, so for example, for each point in time, we should be able to get the features that were available up to that point. So this is something that also prevents data leakage. Yeah, so, and a feature store should ideally also provide some metadata of the features. So one thing that's quite important here is updated list of the feature consumers. So for example, if we detect a bug in our features, and if we correct this bug, we would like to notify all the teams that are using these features in their models. Model versioning. So for example, after we train a model, we would like to version the trained model. So basically, what does it mean? So yeah, so for that we have a tool, it's called Model Registry. And what is it? Is basically, again, some sort of location, some sort of storage where we can push already trained models. So for example, in the pickle format or in whatever format we want to have. So again, model registry is something that allows us, ensures reproducibility, because when we are pushing different versions of the models, we can attach different versions to it, different tags, and with that we are able to retrieve previous versions of the model. It is also a point of collaboration. So for example, data scientists train the model and store them in the model registry, and then MLOps team, for example, can just grab this model and kind of incorporates this model into their prediction service, for example. Again, this is a basis for assessing some model risks or ensuring that the models really are used in an ethical way. There is also, it also allows fast and seamless model rollout and rollback. So basically, if we have some prediction service, then we are able to get new version just by changing the version number, and the new version is kind of pulled from the model repository. And also for rolling back, so if we're not satisfied with the model that we have in production, we can just change the version and return to the previous version of the model. Model registry should, of course, store the model file, but also it's advisable to also store some other parameters, such as model name, architecture, hyperparameters, and metrics. Environment versioning. So what do we mean? What do I mean by that? So, for example, I think that we've all were in situation that we have developed a model. We deployed the same code to our colleague's computer, and it didn't work because of some differences in the libraries and dependencies and so on. So we have, there is a concept, so there is a tool, it's called Docker. It's not the only one, but it's the most well-known. That allows us to take our code, pack it in our environment, and create some sort of image of our environment. And this image, with all the dependencies and everything, can be deployed to other machines and work the same way. So this is also some sort of repository when we can push those images and, of course, version them and retrieve previous versions. So once we have different components, we have to be of our system. We have to also be able to remember how did we connect different components in a sequence. So we have quite a lot of workflow orchestrators available. So these are the tools that allows us to chain different components into a workflow. It has also some other advantages because, for example, we can define what happens if a component fails and so on. They can share different parameters between different components and so on. And why is this good for reproducibility? The good thing is that the workflows are usually defined in either in some configuration files or in, let's say, Python code, or some combination of both. And what's the benefit of that? Simply that we can just push everything in Git and have versioning. Similarly with infrastructure, so there is a concept, infrastructure as code. So if we are developing in a cloud environment, cloud providers allow us to define the infrastructure as code. So instead of clicking in the web browser and, let's say, set up some instance of SageMaker or EC2 or whatever, we can do that in code. So again, we have some sort of configuration file where we can define the infrastructure resources that we're going to use then in our machine learning system. So why does this even matter? So, for example, imagine you're working on some model, you're using some GPU instance, and then MLOps teams gets the model and tries to deploy it in some CPU instance. There is quite a large chance, if you have complex model, that this will break. So it's very important to also keep track of infrastructure. So how do we version it? Again, if we have some configuration files, we can just check them in our source code repository. But this approach also has some other benefit, not just reproducibility. For example, it fosters collaboration because all the people can work in the same infrastructure this way. Then scalability, if we have different resources defined as a code, we can easily just multiply those resources and get scalability, availability, and so on. Okay, so the last thing is metadata store. So one thing that we need here in all this story. So we are tracking all these different versions. But if we want to reproduce our machine learning system, then we have to also remember how this all fits together and which versions of which we are using. So there is a concept, metadata store, and it's basically a place where we can really connect everything together, all parts of our machine learning system, and store basically everything we want from the whole system. So we can store the versions of our data set, environment, configuration, code, some model versions, performance metrics of the models, maybe some computational performance, visualizations, predictions, whatever. So last thing in this chapter, I would just like to kind of show how everything fits together. So what we see here in this diagram is it's a diagram of mature MLOps environment as is defined by Google, as recommended by Google. So let me just walk you through it. So these red parts of this diagram are the parts that kind of help us with to ensure reproducibility. So these are the parts that we have been talking about, just to see how everything fits together. No, oh, no. Okay, I'm trying to get the point. Ah, yeah. Sorry. I have to point here, right? Yes. Okay, so the part here is where the data scientists are developing models. So this is experimentation, development. We can see on the left side of that, we have this experiment tracking, where they can track the results of their experiments. And then over okay, in the next red box, source code, when they are satisfied with their model, with their system, they can check all the code in the source code repository. Then on the top right side, we have the DevOps pipeline, which deploys the system in eventually in production. And then what we see from the second line on, this can be a production environment. So for example, data engineers from the start, so they are in charge of the data pipeline and they compute features which are stored in feature store. And you can see that feature store is used either in development or with training and also in prediction. So from the feature store, we can then train the model, store the model in the model registry, and then from then down, we have our inference pipeline. So the inference pipeline kind of grabs the model from the model repository, uses it with predictions. So of course, if we want to make predictions, we have to use some features. And then we can monitor the performance of our model, and if performance starts to drop, we can then continue to training or go back to experimentation. So in the middle, we have this metadata store, which kind of collects all the informations from different parts together and makes sure that all the dots are connected together. Okay, one last thing, documentation. I'm not going to lose time for that, but I think that we've all been in a position when we started a new project and there was no documentation. So why this is bad? If the information travels from person to person, a lot of information gets lost. So document as you go and really start from day one. So as you have seen, I really like memes. Just a disclaimer, none of the meme in the presentation is mine, so these were all created by smart and funny people on the internet. But I couldn't say thank you without the meme, so thank you.
Thank you, Spela. Love the presentation. Do we maybe have any questions? We do? Oh, we have a lot. Okay, we maybe won't have that much time, but we'll try to do them all.
Thanks for depressing us with all the things that we could mess up. I have questions. You've mentioned a lot of tools in a lot of different parts of the system. What specific tools are you using on a day-to-day basis?
Yeah, so basically there are quite a lot of tools. So first of all, I'd like to mention that all the cloud providers have excellent tools for that. So if you are developing on AWS, you have the SageMaker with all these kind of functionalities, and the same functionalities we can find in either, let's say, Azure or Google Cloud and so on. So I guess this is something that I would go to. But there are also some more kind of lightweight solutions, so open source solutions, for example, MLOps, for example, MLflow, for example, it has this experiment tracking capabilities, packaging models, model registry, for example. They also are introducing MLflow pipelines for defining the workflow, for example. Then DVC has also a lot of this functionality. There are also some proprietary things, software, for example, Neptune AI, which, by the way, have a great MLOps block. I warmly recommend it. So there are quite a lot of tools for that.
Thanks.
Did you take notes? I forgot most of the mental notes. Okay, let's take the next one. Kubeflow is something that I should also mention. It runs on top of Kubernetes and also has a lot of functionality.
Okay, just that question. So you showed this like architecture with all the feature stores and so on.
It's not.
How do you split that in the environment that you described in the beginning? So you have development environment, staging, inference environment. Which part of do you have a copy of this in each environment, or do you have just some parts and hope that they fit together?
Yeah, so for example, you have, let's say you start with the development environment, and this is something that's more relaxed, so people can also have some notebooks there and just try to experiment like that. But once we are happy with what we're doing, it's time to kind of try to put this code more into production code. For example, what we can do is then, let's say in the next stage, we can then introduce the code that's, let's say, if we're using microservice-oriented architecture that's used that's containerized and connected together, and then we can have these into the higher stages. Did I?
Almost. I mean, also the question was if we, for example, should put the experimentation part of pipeline creation only on development environment, and then basically continuous training of the model only on the inference environment, for example.
Only on, yeah. So for example. So we can have different stages of automation at each level. So for example, we are developing, we don't want to be we don't want that this is something automatic. So this normally would mean that data scientists push a button and then the model is trained. But for example, in some higher stages, we can also define our kind of DevOps pipeline so that also some different services can be deployed, and also we can connect them together in more automated way, for example, some automated training and so on.
Okay, thank you.
My name is Mikhail. Thank you very much for this talk. I talk about reproducibility as well for around 3 years.
Oh.
And I'm working in iterative AI. We develop DVC, and it's very glad to see that you're using this tool. I just want to add that DVC can be used not only for data versioning, but also for experiments tracking and models. So it's almost the all stages that you talked about. It's about DVC. My question is about the metadata. You mentioned first that the Git is the right tool, let's say, to do versioning. Do you consider to use Git to store all metadata about your ML system? Not only about versions of data as DVC used, but also about that infrastructure as a code, etc., etc. So this is actually the DVC tools what are trying to do to keep all metadata in the Git. So what do you think about this?
So what do I think about storing all the metadata in Git? Yeah, I think for sure you can do that. For example, you can define just some environment file where you can store different parameters. So this would be from the top of my head that you can then check in.
And how do you do this? Do you have the separate database where you store, or use some separate service to keep metadata about your system, or you still use Git for this?
Yes, I mean it is advised to have some separate storage for that. Yes. So basically, yeah. So for example, in Git, there is a tricky part. So for example, if you have different parts of your pipeline in, let's say, different containers, for example, and you have a separate repository for each container, so basically there has to be some part outside of these repositories, so to say, that kind of connects pieces together.
Yeah, maybe. Oh, okay, so I think we can talk about this later, but yeah, this possible solution for some cases. Thank you.
And thank you for all your questions. You will be able to find Spela at the lunch break, during the lunch break. Thank you. You were great.
Thank you.